Welcome back, everyone. Today's explainer is your ultimate textbook-style guide to mastering digital currency and blockchain for your IGCSE computer science exam. We're picking up exactly where we left off in Chapter 5, moving from the internet and the World Wide Web right into the fascinating world of digital finance. So whether you're prepping for multiple choice questions, short answers, or those heavily weighted structured questions, we have totally got you covered.
Here is our agenda for today. We'll be covering fiat versus digital currency, cryptocurrency and decentralization, inside the blockchain, the transaction process, security features, and finally, a targeted IGCSE exam review.
Section 1. Fiat versus digital currency.
To really grasp the future of money, we kind of need to establish the baseline of what we use today. Write this down for your notes. Fiat currency is your traditional government-regulated money. The word fiat actually comes from Latin meaning "let it be done." Because it isn't backed by physical gold or silver reserves anymore, it relies entirely on the authority of governments and central banking systems to hold its value. So when you hold a physical paper dollar, pound, or euro, you are holding fiat currency.
Now, digital currency, that just takes fiat money and slaps it onto a screen. It exists purely in a digital format as data on a computer system. There are absolutely no physical coins or notes to hand over. When you use online banking, PayPal, or Apple Pay, you're using digital currency. But, and this is a critical limitation for your exam notes, traditional digital currency still relies entirely on a centralized bank to process the transaction. You still have a central authority controlling exchange rates, setting the rules, and acting as a massive single point of failure if their servers go down or get hacked. Make sure to note this single point of failure as a primary disadvantage for your exams.
Section 2. Cryptocurrency and decentralization.
What's really interesting here is how innovators developed a clever solution to the security and privacy flaws of those central banks. Traditional banking routes all your money through a single, centralized system. I mean, if Nick wants to send money to Arena, his bank talks to the central bank, which then talks to Arena's bank. That's a lot of middlemen. Decentralized systems, on the other hand, distribute this power across a massive community network. There is no central server. Every computer on the network helps verify and store the data. This is what we call decentralization, literally removing that single point of failure and stripping away state control.
And this brings us to a massively important keyword for your syllabus: cryptocurrency. It's a form of digital currency that uses cryptography to track transactions across a decentralized network. Real-world examples: Bitcoin and Ethereum. Fun fact, actually, the first real-world Bitcoin transaction was paying 10,000 Bitcoin for 2 pizzas. Can you imagine? Anyway, by removing the central bank, cryptocurrency transactions become regulated by the community itself. There's no government or state control determining exchange rates or rules. It's highly secure, completely independent, and relies on some truly brilliant computer science to function.
Section 3. Inside the blockchain.
The crucial point here is understanding the mechanism that makes this decentralized magic possible. If you are asked to define blockchain on your exam, remember these 2 phrases: decentralized database or distributed ledger. Think of blockchain not as a single server sitting in a corporate office, but as a shared database that every single computer on the network has a copy of. Because everyone has a copy, no single person can secretly alter a transaction without the rest of the network immediately noticing and rejecting it.
Let's see how this actually builds a chain. Every single block in a blockchain contains 4 vital pieces of information. First, the data. Who's sending money to whom and how much? Second, the hash value. Think of a hash as a unique digital fingerprint generated by a cryptographic algorithm called SHA-256. Third, the previous hash value, which physically links this block back to the one right before it. And fourth, a timestamp recording exactly when the block was created. These components lock the blocks together perfectly. A quick memory trick for your exam: just remember DHPT: data, hash, previous, time.
For the exam, you've got to remember a very specific piece of trivia: the Genesis block. This is the absolute starting point of the chain. Because it's the very first block ever created in that specific network, it is entirely unique. Why? Well, because its previous hash value is just a string of zeros. It literally has no preceding block to point back to.
Section 4. The transaction process.
Now, let's trace exactly what happens chronologically when a user sends cryptocurrency to a friend. This process brilliantly illustrates why you cannot alter a transaction without the consent of the entire network. Let's walk through it. Step 1. The transaction is broadcast to the network. Step 2. Every single computer gets a copy. Step 3. The network verifies it using cryptography to ensure the sender actually has the funds. Step 4. A new block is generated with its unique hash and timestamp. And finally, Step 5. The block links to the previous hash, is added to the chain, and every computer updates its ledger. It's a beautifully transparent and democratic process, right?
Section 5. Security features.
But what actually happens if a hacker tries to tamper with the data inside one of these blocks? Well, here is where the absolute genius of hashing comes into play. If a hacker changes even a single decimal point in the data of a block, that block's unique SHA-256 hash instantly changes into a completely different string of characters. But remember, the next block in the chain is holding on to the original hash in its previous hash section. Because they no longer match, the link is instantly broken and the entire rest of the chain becomes invalidated. This is what makes the blockchain immutable, meaning it's totally unchangeable.
Now, computers are fast, like insanely fast. A hacker's computer could theoretically recalculate all the hashes for the rest of the chain in seconds to make the tampered chain look valid again. To stop this, blockchain uses a proof-of-work system. This intentionally slows down the creation of new blocks, forcing a 10-minute delay for mathematical processing. This is policed by special users called miners, who earn a small commission for confirming transactions. Because of this 10-minute delay, hacking the entire chain across millions of distributed computers becomes mathematically and practically impossible.
Finally, Section 6, our IGCSE exam review.
Okay, let's consolidate all this knowledge and test you with some high-yield exam tips based directly on our source material. Take a second to think about the mechanism we just discussed. This is a classic scenario-based question you might see for 4 to 6 marks. How does the blockchain network react to altered data in block number 2 out of a 5-block chain?
Exactly. Now, if the exam uses the command word explain, you can't just say it breaks. You really need to show the step-by-step logic to secure full marks. First, state that changing the data alters the hash of block 2. Then, explain the knock-on effect. The previous hash stored in block 3 no longer matches the new hash of block 2. This breaks the link, invalidating blocks 3, 4, and 5, alerting the entire distributed network that tampering has absolutely occurred.
You'll definitely want to keep this summary table handy in your notes. It perfectly highlights the exam differences between traditional digital banking and decentralized cryptocurrencies. If an exam question uses the command word compare, you must talk about both sides. For example, unlike traditional digital currency, which is controlled by central banks, cryptocurrency is controlled by a decentralized community. Ensure you highlight that traditional security relies on a vulnerable central server, while crypto uses a highly secure distributed blockchain ledger.
I really want to point out this exact quote from your syllabus text because it corrects a very common misconception. A lot of people think cryptocurrency is entirely anonymous and used in the shadows. In reality, while the identities might be hidden behind cryptographic keys, the transactions themselves are incredibly transparent. The whole community tracks the ledger, meaning every single transfer of funds is publicly available to view on the blockchain.
By reviewing these precise definitions and step-by-step mechanisms, you are perfectly equipped to tackle any exam question on this topic. Whether you are defining a Genesis block, explaining the role of SHA-256 hashing, or comparing fiat to crypto, rely on the structured logic we've laid out today.
I'll leave you with that provocative thought. As blockchain technology evolves, the way the world handles money, contracts, and data is fundamentally shifting. Could fiat currency eventually become a thing of the past? Thanks for joining this explainer. Stay completely focused on your revision and keep exploring the amazing, ever-changing world of computer science.